Welcome. So we're going to be doing some application problems regarding the derivative. Here's the first one. These two problems are in your book. The graph of a function g of x is pictured to the right. Identify the following characteristics about the graph of the derivative g prime of x and give a reason for your answers. All right, so the first characteristic, the intervals where g prime of x is less than 0. In other words, g prime of x is negative. Right? On the graph, the values are below the x-axis. So this is where g prime of x, the y values would be below the x-axis. Right? So g prime of x is going to be less than 0, where g of x, the function that it's the derivative for, is decreasing. So from -4 to -2. So I'm going to start my statement here. G prime of x is less than 0 on -4 to -2. And I'll put a U for a union. And 1 to infinity. When we're giving intervals, right, we give the x values. And the reason? Because g of x is decreasing. So the derivative is negative, where its function is decreasing. All right, so now we have the intervals where g prime of x is greater than 0. In other words, the y values are positive. And g prime of x, if we were looking at a graph of g prime of x, would be above the x-axis. By the way, you might need to know that for an upcoming closing. Just saying. All right, so that's going to be here. Right, so from -infinity to -4, so g prime of x is greater than 0 on -infinity to -4, and -2 to 1, because g of x is increasing. Make sure you say g of x and not the function, right? Because g prime of x is a function too, right? And it's not necessarily positive where g prime of x is increasing. It's where g of x is increasing. So make sure you're specific as to which function you mean. And then finally, the values of x where g prime of x equals 0. Right? So that means we have a horizontal tangent line. Right? Because the derivative is the slopes of the tangent line. And in class I said it could possibly be a relative max or min, but not necessarily. You could have, a place where you have a horizontal tangent and the graph just keeps going in the same direction. But not in this case. In this case, they're all relative max and mins. And so in those three places, right? So g prime of x equals 0 at, now this one won't be an interval, this is just at a single location. By the way, don't give the y value, because the y value on the graph of g prime of x is not the same as the y value on g of x. Just state the x values, right? So when you're telling where something is, just state the x values for the derivative here. All right, so at x equals -4, x equals -2, and x equals 1, because, and I'm going to kind of repeat what I have over there, because the tangent line at these values, oops, missing knee, has a slope of 0. And so there are horizontal lines. Right? And that's all there is to figuring out where a derivative is positive, negative, or zero. All right? And as always, if you have questions, you can ask me in class. I have one more problem for us. All right, so definition of the normal line. Picture to the right is the graph of f of x equals negative 1/2 x plus 1 all squared plus 4. Just a parabola, vertex at negative 1, 4. Draw the tangent line to the graph of f of x at x equals 1. Right, I'm going to, oops, see if I can get my line tool to come out. Yes, I did. I'm going to try to make it some other color than black because black kind of blends in on the black graph. Okay. And let's see how I do when I'm recording. Whoops. Well, I may have to straighten out my line just a tad. Let's see. I guess that's not too bad. And so I drew it on the computer, and then I came over to the screen. It's tolerable. Oops. I still have a line tool out. I don't know how. It's not showing a line tool, but somehow it's still there. Don't get rid of that. Here. Oh, I don't want that. I would just ignore that this is happening. Cut. There we go. Go away. Go away, red line. There we go. See, I have an arrow there. I shouldn't have a line tool. All right, we're not going to mess with that tangent. I think that tangent is just peachy keen. We're going to keep that tangent. All right, so we want to estimate the value of f prime of 1. So f prime of 1 is approximately, well, let's see. I go down about 2 boxes. For every 1 box I went to the right. So I would say that's approximately negative 2. And so the best we can do is estimate when we're looking at a graph and not just finding the derivative and plugging in. Find the equation of the tangent line to the graph of f of x at x equals 1. Right? So we have our, we do have our y value. It appears to be 1, 2 to me. And so that would just be y minus 2 equals negative 2 times x minus 1, or y equals negative 2 times x minus 1 plus 2. Right? So no problem there. Last question. The normal line is the line that's perpendicular to the tangent line at the point of tangency. Draw this line and find the equation of the normal line. Right? So the tangent line had at x equals 1. I'll just put that underneath it. At x equals 1, because it'll be different if I choose a different point. Had a slope of negative 2. Tangent line and normal line are perpendicular. That's the symbol for perpendicular. Perpendicular lines have slopes that are negative reciprocals. Right, so if the slope of the tangent line is negative 2, then the normal line at that same point is going to be a slope of 1/2. Right? So it's going to go through the exact same point. Right? So it's going to go right through 1, 2, just like the tangent line did. And let's see how I do with graphing this line. If it was on paper, I'd have no problem. Sometimes my line tool is not my friend. It likes to be just a little difficult. All right, so usually it's hard for me to, let's see how I do with 1/2. Well, I did great with a line of 1/2. How about we put it in the right spot? Let's just get rid of that. Let's start here. There we go. Always helps to get your line in the right spot. There we go. And that looks pretty perpendicular. And it should, because one has a slope of -2 and the other one has a slope of 1/2. Right? So there's our normal line. Let's label them. So this is the normal line. Oh, by the way, I hope you're putting this in your notes. But I'm sure you are. And I'll label the tangent line too. So I even color-coded it for you. So purple is the tangent line. Actually, after the second try, I think my normal line came out pretty good. All right, so we know what the point is. It's going through the same point as the tangent line. So 1, 2 is the point. So the normal line is going to be y minus 2. Oops, I thought I was writing red. Was trying to color code it. There we go. I think now it'll be in red. Y minus 2. So now it sort of matches my normal line. My line's in orange, but the words were in red. Y minus 2 equals 1/2 times x minus 1, or y equals 1/2 times x minus 1 plus 2. And that's all there is to it. And that's all there is to my video. Right? So I hope you enjoyed finding the characteristics of the derivative based on the graph and finding the equation of the tangent line and the normal line given a graph. Thanks for watching. Bye for now.